Hi everyone, this is Shanshou, and together with my teammate Mason Wang, we built the DocMind. It's an AI-powered research agent platform, and here's the problem we were trying to solve. As students, we constantly accumulate lecture slides, research papers, project documents, and course notes across multiple classes. But when it actually comes time to study or review, finding the right information buried in dozens of PDF is slow, frustrating, and frankly kind of terrible. So we ask the question, what if a document could just answer your questions? And that's how DocMind comes. So first, what is DocMind? DocMind is a full stack web application that lets you first upload your documents like PDF, Markdown files, text notes to build a personal private knowledge database. And second, you can ask a question in English and get intelligent, studied answers powered by an AI agent. And the target audience is anyone who works with a lot of documents, students, researchers, or knowledge workers. And you don't need to really understand how RAG or vector worker. You just need to upload and ask. And yeah, so let me show you how it actually works. So you can see in this app, we have chat, we have documents part, we have setting part. And the first thing first, we have to log in with our Google account. And you can see it's very straightforward to show your account here. And then second, let's go to the main dashboard. Let's upload a research paper. It's a tree of sorts. And let's do it. So you can see the status is changing, it's pending, processing, and now it's ready. So after it's ready, we can go to the chat part and ask the question on the file. So I will type a question about the paper, like maybe what is the tree of thought? And let's wait for a few seconds to let it generate the answer. Yes, and here it comes. It gives us the answer in very structured way because you can see the first is the summary and the second is the key points and the third one is the evidence. So I think this can give you not only a conclusion but also how it counts. You can see this the sort of tree is a new framework for language model inference that generates in chain of thought approach. And enabling language models to perform deliberate problem solving. It allows LM to explore reasoning past over thoughts, which are coherent units of text serving as an intermediate step towards solution. Yeah, I think that's a good answer because that basically is the concept of the tree of thought and give you the key points, the evidence, like source one, source two, to the source 10. And you can see it's from this file. And so let's ask maybe another question that's not relevant with our document just uploaded. Maybe how to cook avocado. Yeah, because actually that's my favorite fruit. Let's see what it will be. Okay, so you can see it give you the answer like the probability contest does not contain any information on how to cook avocado because we didn't have this kind of documents, and the only document we upload is the tree of thought. So you can see it will not generate hallucinated answers based on your documents and just answer randomly. It just will tell you is doesn't have this kind of information. So I think can make sure that it won't lie to you in the greatest possibility. And yeah, so I think this is the core of DocMind. Now I will hand it to my teammate Mason Wang to talk about how we build this. And thank you.
So thanks Shanshou for his part of the presentation. My name is Yachen Wang, but you can also call me Mason. Let me walk you through how this system is actually built. So DocMine is a full stack application with three main layers. The first one is our front end, which is built with Next.js, TypeScript, and also Tailwind CSS. The streaming UI you saw uses service and events to display all the agent's response as it's being generated. Also, for our backend, we're using a Python fast API server that will handle document processing and exposes all of our REST endpoints. The document uploads will trigger auxiliary workers, which are background processes that will handle the heavy lifting of text extraction, chunking, and embedding generations. So the main API thread will always stay free. For our AI agent, which is the heart of DocMine, we're using LangGraph to build an orchestration agent that will route each query to the right tool, such as our knowledge base retrieval, which is using a hybrid of BM25 keyword search and also semantic vector search. Our agent is also running on Gemini. And last but not least, our data lives in Supabase, which is a PostgreSQL database for our structured data, PG vector for embeddings, and also Supabase storage for all of our raw files. Role level security also enforces that each user can only access their own documents. So AI was deeply integrated into our development process. We mainly use anti-gravity with Cloud Opus at first, and then since we run out of token, we started to use Codex on VS Code for all of our code generations. Other repetitive tasks like writing the fast API route handlers, TypeScript interfaces, and also Supabase query boilerplate were dramatically faster with all these AI assistant tools, which freed us to focus on the harder architectural and design decisions, which we also uses AI to scan the entire workspace, create a sour plan for us to review, and also then implement and test on its own. When we hit tricky bugs, AI was also a very valuable debugging companion. Rather than spending hours reading through all the documentations, we could paste on error trace and get targeted, actionable suggestions almost immediately. So overall, it significantly reduced the time we spent stuck on issues that wasn't central to our project's goals. So moving forward, here are some of the challenges that we've encountered that I would like to highlight. The first one is our chunking strategy. So for the early versions of our app, our pipeline chunk documents very naively by fixed token count, which caused the agent to retrieve context that was semantically incomplete. For example, maybe if you give it a sentence, it will in a document, and then it will cut the sentence in half. Or maybe you give it a table and it will split into a different like in even chunks. So we had to invest a lot of time into this, especially Shanshou, to make a smarter chunking logic that respects the document structure. Also, there were some overlapping work issue. Uh, so early on, we had a miscommunication about our task ownership. Although we clearly divided into back end and front end, but while we are actually building it, a lot of time we're actually doing the others' work without knowing. Like when Shashu was building the authentication thing on the back end, so he basically also built a simple logging UI for testing and also local access. Well, I was basically simultaneously building my own logging UI on the front end. So neither of us knew the other was doing the same thing. We eventually caught it during the check-in and merged the work successfully after solving other merge conflicts. But it was a reminder that clear communication matters as much as clean code. And after that, we also increased our sync frequency and also made a habit of explicitly confirming who and what before starting any new piece of work. And last but not least, also there was some front-end scope creep. Basically on my end, I made the mistake of defining my issues too broadly at the start. So I think on a ticket, it mentions to build authentication, the logging, also the documents UI. So basically, while doing it, what looked like one task often turned out to be several, and each piece took longer than I anticipated. Some of the ideas I planned for early on didn't get implemented till late, and by then maybe the design had evolved enough that I ended up have to remove them entirely. So looking back, I think that time could have been better spent, maybe helping Shanshou in the development of backend. Also going forward, I want to basically just break work into smaller things, more concrete issues, maybe from the beginning, so I can stay more flexible about reprioritizing when things shift. So, as for the team collaboration part, Shanshou and I divided our ownership clearly from the start. Shanshou took primary responsibility for the backend, the long graph agent, and also the Celery pipeline. For me, I own the front end, the streaming UI, and also the Supabase auth integration. We use GitHub for version control with feature branches and pull requests. So even as a two-person team, our discipline saved us multiple times from overriding each other's work. We also did a lot of daily async stand-ups via Zoom meetings to flag blockers early as we pair programmed on a lot of the trickiest integration points together. All right, so towards the end of this video, please think of it as a walkthrough of our technical blog post. We just wanted to give you an honest picture of not just what we built, but also the hows and whys, all the design decisions, the rough edges, and also what we do differently. Overall, the project started as a solution to our own frustrations as students, but it ended up being a genuine useful tool. And also for us, a deep dive into topics such as agentic AI systems, async architecture, and also full stack engineering. So thanks for watching, and please have a great day. Thank you.